Now we're going to work on completing a more complex Venn diagram. Based on polling some students, 35 students were polled, 16 students live on a farm, 17 students have a sibling, 28 students have a sibling or have a pet, 3 students who live on a farm, own a pet and have a sibling, 5 students have a sibling and own a pet, 11 students live on a farm and have a sibling, finally 26 students own a pet or live on a farm. Our first step to solving this is to first of all determine what A, B, and C are going to be. So in this case, we're going to say that A is live on a farm, B is have a sibling, and C is own a pet. Our next step is to turn each of these statements into set builder notation using the A, B, C, union, and intersection symbols. Let's start off with the 16 students live on a farm. So we said that the farm is A, so A is equal to 16. 17 students have a sibling, so B is equal to 17. 28 students have a sibling or a pet. So sibling is B, pets are C, so that is an OR situation. B or C is equal to 28. 3 students who live on a farm own a pet and have a sibling. So in this case, all 3 come into play. So 3 students who live on a farm, own a pet, and have a sibling, so that's all ands. So it's A and B and C is equal to 3. 5 students who have a sibling own a pet. So that's just B and C again. Remember previously here, this was an OR. We had an OR siblings and pets, but it was an OR situation in that case. 11 students live on a farm and have a sibling. So that's A and B is equal to 11. And 26 students own a pet or live on a farm. So A or C is equal to 26. Now let's map each of these into the Venn diagram. We'll start off with the AND statements first. First one I'm going to work with is the A and B and C. And it says there are 3. So that's the intersection of all 3 circles. Now we've got intersection of B and C is 5. However, now with that 5, we've already got 3 here that are both in B and C. So what's left then is 2. So for this statement to be true, it's what is in B and C. And so if you look at circle B and circle C, it now equals 5 because we've got 3 and 2. Now we've got A and B is equal to 11. Similar situation. We've already got 3 there, so we've got to take the 3 away from the 11, which leaves us with 8 left over that's in between A and B. So if you look at the intersection of A and B, you see that this space here is the intersection between A and B, and now it contains 11. That's taking care of all of our ands. Now we want to use logic to try and fill out the rest of the gaps. I've just about got B finished off, so I'm going to look at the information I've got here tells me that B has a total of 17, and right now I've got 13, so the remainder there is going to be 4. Now things get tricky. We've got 3 pieces of data that we haven't used yet. The A being equal to 16, the B union C, and the A union C. Somehow we have to use those 3 pieces of information to figure out what's left in these 3 spots. To do this, we actually get back to using some of the algebra we've used previously. I'm going to define each of these spaces to be a variable, x, y, and z. Now when you look at everything, let's take A for example. We know that A is equal to 16 as we've set up here. We know that if we take x plus y plus 3 plus 8, we need to end up with that 16. So I'm going to write that as an equation. X plus y plus 3 plus 8 is equal to 16. And I can simplify it a little bit then to say x plus y is equal to 5. I've subtracted the 3 and the 8 from that side, subtract them from the other side, and I end up with 5. So there's one equation I've got now. I'm going to do something similar with C. I also now know that using this last piece that A union C is equal to 26. So A, which we've said is 16. Now if I take the A union C, it says that you can either be in A or C. So let's see how that works when we add up using algebra again. That's giving us 8 plus 3 plus 2 plus x plus y plus z is equal to 26. And if we simplify that a little bit, we end up with x plus y plus z is equal to 13. That gives us our second equation. Now our final piece of information, the one that I left highlighted here in yellow, B union C. So again, that's an OR situation. Everything that's in B or in C, we already know that B is 17 plus y plus z is equal to 28. So y plus z is equal to 11. And that gives us a third equation. We haven't done 3 equations with 3 unknowns, but you actually have the knowledge from doing 2 equations, 2 unknowns, to solve this problem. One of the things to notice is you've got an x plus y equals 5. And in this equation, for example, the second equation, you also have an x plus y. So you remember substitution methodology. You can take that x plus y equals 5 and substitute it into that equation. So x plus y plus z is equal to 13. We're going to substitute in 5 for the x and y. 5 plus z is equal to 13. So z, we can find, is then equal to 8. So we've actually now found a value that we can substitute in. Now that I've got one variable, I can take that information, I've solved for one variable, and I can put it into one of these other equations where I've got y plus z equals 11. I can now say y plus z is equal to 11. So y plus 8 is equal to 11. So y is equal to 3. And now that I've got y equal to 3, I can substitute back into my last equation, x plus y equals 5. Put that in for y. So we've got y equal to 3, x equals 2, and z equals to 8. I can go ahead and plug those final numbers into my Venn diagram. Now my Venn diagram is complete. Try the practice questions in the workbook and check your answers against the answer key.